Hello students, we are solving the IB Math AHL past papers and currently we are solving the IB Math AHL May 2022 paper 1 time zone 2 past paper. Today we will be solving the question number 11 of this paper and you will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in my channel NS Online Math Tutoring Classes. So, without any further delay, let us start answering question number 11. The maximum mark is 20. A function f is defined by f of x equal to 1 over x squared minus 2x minus 3, where x belongs to the set of real numbers, x is not equal to negative 1 and x is not equal to positive 3. So part A says sketch the graph of y equals f of x, clearly indicating any asymptotes with their equations. State the coordinates of any local maximum or local minimum points and any points of intersection with a coordinate axis. Okay, so actually I have already drawn the two axes, the x-axis and the y-axis, and I have drawn the two vertical asymptotes as well because x is equal to not equal to negative 1 and x is not equal to positive 3. That means if I factorize this denominator, we will be having x plus 1 and x minus 3. Okay. This will be the factorized form because 1 times negative 3 is negative 3 and this will be 1 times x is x and negative 3 times x is negative 3x. So x minus 3x is minus 2x and x times x is x squared. So this is the factorized form of the denominator. So you will be having the equations as the vertical asymptote equations as x equal to negative 1 and x equal to positive 3. These are the vertical asymptotes. And since the degree of the denominator is 2 and the degree of the numerator is 0 because it is a constant term, this can be written as 1 times x to the power of 0. So degree of the numerator is less than the degree of the denominator. So the horizontal asymptote will be y equals 0. That is the x-axis. Okay. So I have drawn these two asymptotes and this is actually, where should I be writing? This is x equal to negative 1 and this is x equal to positive 3. Okay. And now coming to the, and y, the x-axis is the horizontal asymptote. Fair enough. And is there any y-intercept? For the y-intercept, x will be equal to 0. So x square is 0, minus 2x is 0 and 1 over negative 3. So the y-intercept will be negative 1/3. So I have taken this as negative 1. So negative 1/3 will be over here because this is negative 1/3, this is negative 2/3 and finally negative 3/3 is negative 1. Okay. So this will be the y-intercept. This is negative 1/3. Okay. And they are saying another thing that we have to get is, do we have any 0? That is the x-intercept. Definitely not, because for x equal to 0, the y should be, for the x-intercept rather, the y should be equal to 0 and we are having the numerator as 1. So y can never be equal to 0. And we are also knowing that the x-axis is the horizontal asymptote. But still we can test for zeros because uh, a function graph can cross the horizontal asymptote for small values of x. That is why I was searching for zeros. But this function doesn't have any zero. Now coming to the maximum or minimum points. Does it contain any maximum or minimum point? By the two vertical asymptotes and the horizontal asymptote, it is very clear that it will be having three portions, and the the left hand side and the right hand side should be like this, because x-axis is the horizontal asymptote. Therefore, this side should be this way and this side should be this way. Okay. Coming to the middle section, do we have any maximum? Because it shouldn't be maximum, it cannot be a minimum point, because this side it has gone up. Okay, let us even then let us check. For that we need the f dash x value, and we have to equate it to 0. F dash x expression, and we have to equate it to 0. So if I take this expression for f of x, the factorized form, f dash x will be, I'm using the quotient rule. So this is x plus 1 whole square and x minus 3 whole square. And this one is u and this one is v. So the first term will be u dash v. U is 1, so u dash is 0. So the first term, we do not have any first term, any two terms. The second one will be negative u dash v minus u v dash. That is the numerator for the quotient rule. So over v square. So we have written the v square part. So it will be minus u v dash. Minus, and u is 1, so I'm not writing it explicitly. And v is having two linear factors, so I'll be using the product rule for differentiating this v. If I differentiate x plus 1, I have x minus 3, and if I differentiate x minus 3, I have x plus 1. Okay. Okay, so this will be giving us 2x, and minus 3 plus 1 is minus 2. So it is minus, because there is the minus sign in front. So it is minus 2x. Minus 3 plus 1 is minus 2, and this is minus, so plus 2. And there is the denominator, of course, x plus 1 whole square and x minus 3 whole square. And f dash x should be equal to 0 for any stationary point, maximum or minimum. So this rational function is equal to 0. Therefore, minus 2x plus 2 should be equal to 0. I'm writing over here because below I'm having another subpart to be solved. So minus 2x plus 2, I can take minus 2 common. And so x minus 1 should be equal to 0. And minus 2 is definitely not equal to 0. Therefore, x should be equal to 1. Okay. So x is equal to 1. Okay. This should be the x coordinate of the maximum point or the minimum point. We are not sure of that. But first of all, let me get the y corresponding y value. So when x equal to 1, what is the function expression? Function value rather. F of x is equal to 1 over, this is 1 plus 1 is 2. I'm taking this part. So 1 plus 1 is 2, and 1 minus 3 is minus 2. So it is minus 2. Therefore, we are getting the value as negative 1 over 4. So the point will be 1 and negative 1 over 4. This will be the a stationary point. Now we have to see whether it is a maximum or a minimum. Okay. So let me just get it over here. If I take this, it is just above the graph, and I am having x equal to 1 is the 0. This is 1. This is 3, the vertical asymptote, and this is negative 1. 1 and minus 1, the distance between 1 and minus 1 is roughly the same as the distance between 1 and 3. Don't consider these things. I'm just numbering, I'm labeling the points so that you know this is minus 1 and this is S3 and this is 1. Okay. These two are the two vertical asymptotes, and this is the f dash x sign diagram. Okay. So for this part, I'm taking x equal to 0. So what happens? And I am using this one, f of x. So this is x plus 1, 0 plus 1 is 1, and 0 minus 3 is minus 3. 1 times minus 3 is minus 3. 1 over negative 3. That is in fact, the y-intercept. So it is f, oh, sorry. Uh, I'm taking, sorry, this is a common mistake that students do, and right now I was also doing the same mistake. Since I am drawing the sign diagram of f dash x, I should be taking this expression and not the f of x expression. So for x equal to 0, this is a positive and this is positive because these are whole square. The denominator is positive and x equal to 0, so the numerator is plus 2. So for x equal to 0, f dash x is having a positive value. And for this side, I can take x equal to 2. If x equal to 2, I'm not considering the denominator because these are whole squared. So these will be positive. The denominator will be positive. We are not concerned about what is the numerical value of the denominator, just we are concerned about the sign. The denominator is positive regardless of the sign of x. But what is the numerator? It is x is 2. Negative 2 times 2 is negative 4 plus 2 is again negative 2. Fine. So it is from positive to negative. F dash x is going from positive to negative around the 0 x equal to 1. So therefore x equal to 1 is the x coordinate of the maximum. And for here, this left hand side, if I take negative 2, you will be seeing again the denominator will be positive, and negative 2 times negative 2 is positive 4 plus 2 is positive plus 6. So this is f dash x is plus, so it means it will be increasing. See, the function is increasing in this region. And for this part, the rightmost part, if I take x value as 4, so minus 2 times 4 is minus 8 plus 2, it is negative. Denominator is positive. Numerator is negative, so this is negative. That means the function will be decreasing in this region. The function is decreasing in this region. So we have got this will be maximum. The x equal to 1 will be corresponding to the maximum point, and we have got the coordinates, x and the y coordinates of the maximum point. And this is minus 1, so this will be minus half, and this will be minus half, and maybe slightly above, it will be minus 1/4. This is 1 and negative 1/4. Okay. So this one is 1 and negative 1 over 4. Okay. And now we have to sketch the middle portion. So it will be roughly this way. Okay. And this is the graph of f of x equal to 1 over x square minus 2x minus 3. Okay. So we have shown the asymptotes and we have shown the y-intercept. We have shown the maximum point. We are done with subpart A and we have got 6 marks. A function g is defined by g of x equal to 1 over x square minus 2x minus 3, where x belongs to the set of real numbers and x is greater than 3. That means this part, because the expression of f of x and g of x, they are identical. But for f of x, the domain was x is any real number, x is not equal to negative 1 and x is not equal to positive 3. But for the domain of g of x is a real number greater than positive 3. Okay. Why did they take this domain? Because they are saying the inverse of g is this. Okay. Because in order to have an inverse function of a function, the function should be 1 to 1. And this f of x is many to 1. Therefore, we have to convert it to 1 to 1 to get its inverse. So they have taken the rightmost portion and that they have named that part as g of x. That is the portion which is named as a separate, having a separate name, g of x, and x is greater than 3. X is a real number. So that the g inverse of x is equal to this. Okay. So, okay. So we start with g of x. We write this as y equal to, in place of g of x, I am writing y, and this is x square minus 2x minus 3. And now I will be writing x in place of y and y in place of x. So this is x equal to y square minus 2x minus 3. So, and I am multiplying both sides by y square minus 2x minus 3 and I am dividing both sides by x. So I am getting y square minus 2y 2y minus 3 equal to 1 over x. Okay. And y square minus 2y minus 3 and be written as y square minus 2y plus 1 minus 4, because plus 1 and minus 1, I'm adding plus 1 and minus 1, and minus 1 minus 3 is minus 4, is equal to 1 over x. And this is y square minus 2y plus 1 is y minus 1 whole square, and 1 minus 4 is minus 3. I can take that to the right hand side, or I can just add plus 3 to both the sides. Sorry, not plus 3. I have taken these 3. So I have to add plus 4. Sorry. Y minus 1 whole square is these 3 and we are having minus 4. So I am adding plus 4 to both the sides. So it is 4 plus 1 over x. This is equal to 4x plus 1 over x. Okay. And 4x plus 1 over x, fine. but I need 4x square plus x. Okay. So let us just multiply the numerator and the denominator by x because I need it. I'm multiplying the numerator by x, so I am having 4x square plus x, and the denominator also I'm multiplying by x, so it is x square. Okay, so y minus 1 whole square equal to 4x square plus x over x square. Here, and this is, and now I am square rooting both the sides. I am taking the square root of both the sides. So this is y minus 1 equal to plus minus under root 4x square plus x over x square. And I'll be taking out this x square, so this it will be x. Okay, but and this will be y equals 1 plus minus that. But we are saying we are having only the plus sign. So we have to in fact reject the minus sign. Why should we be rejecting the minus sign? Let us see what is the domain. In fact, in the II, they have asked for the domain of G inverse. So from this graph, this portion, this is G of x. From this graph, I am seeing G of x domain is, sorry, domain is x greater than 3, and that is they have given, and range is y is greater than 0 because it is all positive values of y we are having. So range is y greater than 0. Therefore, for G inverse function, domain should be x greater than 0 and range should be y greater than 3. Now, if I take, so this is y is equal to 1 plus minus square root of 4x square plus x over square root of x square is x. So this is this. Now, should we be keeping the plus sign or should we be keeping the minus sign? We are seeing y is greater than 3 as the range of the G inverse function. So if it is 1 minus, then it will be lesser than 1, smaller than 1. But we need more than 3. Therefore, obviously, we have to keep the plus sign. Therefore, y is equal to G inverse of x is equal to 1 plus 4x square plus x over x. Because range is y greater than 3. Okay. And this one is in fact the II domain. I have written it over here, but even then I'm writing it again. Domain of G inverse of x will be is x is greater than 0. Okay. So we have Answer subpart B. Let me bring in the next subpart. A function h is defined by h of x equal to arctan of x over 2, where x belongs to the set of real numbers. Subpart C's question is given that h of g of a equal to pi over 4. Find the value of a. This is given. We have to find the value of a and give your answer in the form of p plus q over 2 multiplied by square root of r, where p, q and r belongs to the set of positive integers, and g of x expression is 1 over x square minus 2x minus 3, where x is a real number and x is greater than 3. Okay, so h of g of a. h of g of a. What is g of a? We will be putting a in place of x. So this is h of 1 over a square minus 2a minus 3. And what is this equal to? H of x is arctan of x over 2. So x is this part. So this is arctan of, in place of x, we will be writing this. Fine. So this is 1 over a square minus 2a minus 3 divided by 2. And this is equal to pi over 4. Okay. So we can write this as 1 over 2 times a square minus 2a minus 3 equal to 10 pi over 4, which is equal to 1. Yeah. And now let us multiply this entire equation by 2 times a square minus 2a minus 3. So the left hand side is 1 and the right hand side is 1 times this is this. So 2 times a square is 2a square. 2 times negative 2a is negative 4a. And 2 times negative 3 is negative 6. So we are having 2a square minus 4a minus 6 and minus 1. If we add minus 1 to both the sides, we are having negative 7 equal to 0. Okay. And because they are saying that a will be of this form, it's obvious that I cannot use the middle term splitting. I have to use the quadratic formula. So a is equal to minus b, which is minus 4 is b. So minus of minus 4 is plus 4. Plus minus square root of b square minus 4 whole square is 16. Minus 4 times a is this. Don't get confused with that a and this a. They are not the same. A in the quadratic formula is the coefficient, referring to the coefficient, which is 2 in our case. 4 times a times c is the constant term, which is negative 7 over 2a. That is 2 times 2. 2 times 2 is 4. So 4 over 4 is 1. 1 plus minus, and this is negative times negative will be positive, and 4 times 2 is 8. 8 times 7 is 56. So this is 56 plus 10 is 66. 66 plus 6 is 72. 72 over 4. But I have to have a single value of a. We are having 1 plus minus square root of 72 over 4. So which sign should I be rejecting? See, over here we had taken g of a. G of a. And over here you're seeing g of x. X should be a number greater than 3. So A should be a number greater than 3, otherwise I cannot input that in the G function. Okay. So if I take 1 minus square root of 72 over 4, that will be giving us a number which is less than 1. But I need the value of A to be more than 3. So therefore, it is obvious that we have to take the plus sign. Okay. So or A is equal to 1 plus square root of 72 over 4, because A is greater than 3. And 72 is how much? It is 36 times 2, right? 36 times 2 is 72, right? And 36 is 6 square rather. So I can write, therefore, A is equal to 1 plus 6, 6 root 2 over 4. And this is 2 times 3 and this is 2 times 2. So this is A equal to 1 plus 3 over 2 times root 2. Okay. P is equal to 1, Q is equal to 3, and R is equal to 2. All are positive integers. Clear? So this is the answer for the A. This is the value of A. And we have completed solving the question number 11. Okay. So thank you for staying with me till the end. I am Nilanjana Sanyal. I am an online IB Math A, SL and HL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring services to my students. And since you have stayed till the end, I believe that you have liked my video. Please to give this video a like and please to share this video with your friends so that even they can get benefited by watching this video. And please do subscribe to my YouTube channel. It will be motivating me to make more math videos for you. And we meet again very soon in our next lesson, next session rather. We'll be solving the last question of this paper, that is question number 12. Till then, bye.